So today's talk is about the Zephyr Workbench. This is a VSCode extension that we have developed so we can try to simplify the getting started and way beyond getting started with Zephyr, and to do some many options and features that we have in Zephyr that they might not aware that they exist, and to expose them and do all of these features like in simple steps. So firstly, I will start by presenting myself. So I'm Jamil. I am a training engineer at AC6. I have a PhD on real-time operating systems, and I'm technical steering committee representative, and I have authored a Zephyr training course, and also we provide training and support on Zephyr and Linux. So AC6, the training company I work for, it is specialized in embedded system training for over 20 years, and we focus mainly on real-time operating system, Linux, security, and many other things, like FPGAs, architecture of processors, and so on. And we have developed several IDEs. One of them is System Workbench for STM32. This is the ancestor of STM32 Cube IDE. We have more than 150,000 downloads of this IDE. It is Eclipse-based. We stopped maintaining it in 2017. And we have also other IDEs that we have developed for other companies. And we have also Zephyr Workbench. This is the VSCode extension for developing Zephyr. So regarding the course, the Zephyr training, so we have a Zephyr training course that covers the basics to advanced things in Zephyr. It is a 5-day course from configuring Zephyr, drivers, subsystems, and many other things. And we are also Zephyr members. So the purpose of this talk, just to show you Zephyr Workbench that makes Zephyr development much easier, and to explain why it matters, especially for Windows users, because this is, well, many of us may have already used Zephyr, but probably we're using it on Linux. It is much easier to get started on Linux, but on Windows it's a bit tricky. And to demonstrate how it lowers the barrier to entry and accelerate the Zephyr adoption, because most of developers in most companies, they just want one click and it works. And this is something that's pretty not easy to do it on Zephyr. And also to inspire both beginners and pros to try it for the next Zephyr projects, and maybe also contribute back and helping us developing more this IDE, this extension. So why we have done this? So because for us, the first steps were really tough, especially on Windows. So I don't know if anyone has tried to install it on Windows. Yeah, just give it a try. Yeah, I give it like an example, like debugging quantum physics with printfs. Yeah. So why VS Code? Firstly, we wanted to start with Eclipse because we really like Eclipse, but we noticed that nobody in the community really likes Eclipse. So we said, okay, let's do it with VS Code then. So why fighting it? So let's do and use VS Code. And we wanted to keep the one-click solution because this is the best solution. And Zephyr is like this way, like West build, just one command solution. Why not also keeping the same concept? And we have looked at the solution that we have. Each vendor also have its own solution. And there are some have this one-click solution, which work very well. But we can also take this one step further and making it open to everyone. And doing everything also the Zephyr way, because each vendor is doing it their way, and they might also be interested in the Zephyr way using West debug or West debug servers and so on. And we want to make it also open source. So the problem that this extension is trying to solve, we want firstly to solve the complex setup. So Python, which version of Python, what are the dependencies? Installing Python on Windows might conflict with other versions of Python. So how to fix this problem? You might need Python for other things on your computer. So you might be installing a global version of Python that might conflict with your local version. So you might decide not to use Zephyr. I don't know. It's also Python really, I always have bad experience with Python. I don't know you, especially with different versions. And CMake, Ninja, SDK, also they have different versions of the SDKs, Zephyr SDKs. wget, it works on Windows, and we actually need it for Zephyr on Windows. So especially on Windows, so we might have a lot of problems. And besides like getting started, Zephyr itself has a steep learning curve. This is why we have our training actually. So, but if someone like really trying to get started, only the first step is going to stop them from adopting Zephyr. And also the time lost fighting the tools instead of like building applications. And we have inconsistent environments across teams and really hard to reproduce the same setups. So why it matters? Because for beginners, it lowers the entry barrier. Anyone can go from 0 to Blinky in few clicks. And it removes the fear, where do I even start? When you use this extension, it will guide you like, we should click here, then here. If you do a wrong click, it will tell you, okay, first you must click the other option. Yeah, I always insist on Windows, and insisting on it is still the most popular OS, even though we don't like it. So for professionals, it saves hours of manual setups. It works inside VSCode. It ensures repeatable projects, and we focus on coding and not missing dependencies and editing path variable. I would like also to add something that we usually like when we know how to use Zephyr, that's fine for us. But try to explain to your colleagues how to set it up. Oopsie. Is it working this? It seems like the power.
Yeah, there is a switch. There is a switch on the back. On the back towards. That was us. That was us. By the cord.
The cord? Oh, on the other side. Still not working.
But there are other wall plugs. Maybe they could do.
Yeah.
It's not plugged. Yeah.
Thank you. You saved my life. Thank you very much. Yeah. Okay. We're saying that, for professionals, we're just going to spend a lot of time editing path, editing variable to get it started, and try to do it for your colleagues. It is also really complicated. And firstly, they won't understand most of the time what we're doing. And even though if understood, they will not going to really understand how to reproduce it. And it's going to be complicated to have it like on scale, like imagine like you have 10 colleagues that you want to set up the environment for them. Well, it means that Zephyr is going to stay only for few people, not open to everyone. Because we might be very good in development, but setting up the environment, it might be very hard, so we will stop adopting Zephyr. So the challenges we have, we simplified them in 3 different categories. The first one is the host tool dependencies, running the WES commands, and flashing debugging. There might be also other things, but let's just focus on the 3 main things. So installing host dependencies, like installing Python, CMake, and other things. And here we have many different operating systems, Windows 10, Windows 11, Windows, the company, that you have security issues and restrictions. We cannot execute binaries. Yeah. And Linux, so is it Ubuntu? Is it something else? Well, it's also a bit complicated. And which version? macOS, ARM, Intel, and many other versions. Anyways, with WES commands, we just need to import the project, build it, configure it, and WES has hundreds of commands. So beside this, we need to flash and debug. And here, not only flashing and debugging, because we also need to interface with VSCode to have the debug session and the graphical interface part. And the idea we want is just one-click flash and debug, which is tricky. So we need to install, and also we need to install and find the different runners because each vendor has different runner. Like ST, they have Cube STLink or OpenOCD, and we have PyOCD, we have an NXP Linkserver, we have JLink. Yeah, and even PyOCD, I've noticed like some vendors, like ESP32 doesn't have the same OpenOCD that is used by the rest of the community. Yeah, so try to figure this out. So we need to, and also installing them, from where to install it. Google might help, but not all the time, and ChatGPT might get you even more confused. So the solution is the solution that we suggest. So for installing host dependencies, we created a script. It's called ZInstaller, and this script is going to automatically install the host tool dependencies. Well, for now, it works on Windows 10, 11, Linux, Ubuntu, 20, 22, 24, and the macOS ARM. It used to work on Intel. I don't know what happened with it. It stopped working. Yeah. It is fast, repeatable, and reproducible because we make sure that we always have the same setup. By the way, I'd like to highlight something here about Python. Python, we have tried to install Python globally, and we have noticed that each time we have conflicts with different Pythons. So we found a solution for that. On Windows, there's a project called Windows Portable or something like that. So it solves the problem. So instead of using the global setup of Python, we have our own setup. And for the Linux, we have also an open source project. It's called Python Portable. We can rebuild Python with our options. So also we make sure that it's like the Zephyr SDK, but we rebuild it for Python. And Mac. Linux and Mac, they have the same thing. Regarding VSCode, we need to execute or run the different tasks. So we create a list of tasks.json, and we have buttons instead of shell commands. Well, some might still interested in shell commands. This is not a problem. You can do right-click open terminal. You go back to your traditional shell commands. But I would suppose that most people will prefer the buttons. Not me, but not myself, but most people. Okay, so also we share tasks, so it is consistent, and so on. So regarding debugging, we have a bunch of launch.json, one-click flash and debug. It supports the different ones. By the way, here we would need some help from other vendors to make sure that we have the correct ones and give the reference to the different debuggers. So we do breakpoint, step over. We can even have the SVD the SVD that to show all the peripherals. If you provide this one, you can have it. So in brief, what is the purpose? So having Zephyr with VSCode that runs on different operating systems. Pretty simple. This is the objective. But to achieve that, it is really hard. Very, very hard, actually. So the concept is to create Zephyr Workbench. So Zephyr Workbench, it looks like a kite with the wind, but I'm not sure if it looked, this is what we tried. Didn't work very well. We're open to suggestion, by the way. So it is a universal VS Code extension for Zephyr for any supported platform by Zephyr. So any vendor, which is the concept of Zephyr, by the way, because Zephyr, we wanted to make it work on any platform so we can easily switch between different vendors and different boards. So there you go. This is the idea. So how to get started? Firstly, of course, we go to the marketplace, we install VS Code. Yeah. And we go to the extension. Let me see what happens. Yeah. So when you open it, the only thing we need to do is just to click one button, install host tools, and it will just, depending on your internet connection, it will just do some things, install the different, you see it is called the WinPython something that is installed. Anyways, you see that it's pretty quick, and at the end it will do verification, just make sure all the dependencies were installed. So you can see here Python, C, make it small, but you have just verify all the dependencies were correctly installed. So the second step is usually installing the SDK, the Zephyr SDK, and we also have So installing Zephyr SDK might have different options. So Zephyr, if you follow the guide, they will tell you install and export the SDK, make it a global install. Yeah, well, that's fine if you have one project or you not. Well, it works as getting started, but cannot go let you go beyond that. So sometimes you need, or many times you need different versions of SDK. And even with the same version, we might have different dependencies. So we might need 2 different installs. So here we can just do select Zephyr SDK. I want the official source. So we have full, which is the one that has all the tool chains. It takes a couple of gigabytes. I don't usually like it. We don't need this many. So we go with the minimal most of the times. We specify the version. The version is like a drop list. We'll just fetch the different releases. You select the architecture that you have. So let's say we have ARM, and import. It will download everything. Pretty straightforward. I think this step is not the hardest step with any extension. We also support IAR because IAR is pretty nice. So we can just specify IAR toolchain. By the way, IAR toolchain need to be attached to a Zephyr SDK. This is their setup. So you can just select it and you can continue. So the second step is importing West Workspace. West Workspace, we have a bunch of templates. Here, by the way, we would like some help. So the template is like hard-coded for now, but if someone, or it is on the roadmap, just to have like a West manifest editor, so you can actually manually select whatever you'd like with the different projects. So this minimal, it is hard-coded like a bunch of West projects. Like only the minimal things, like ChemSys, for the libraries, and the HAL. And here for the HAL, we can, for example, HAL NXP, HAL ST, and just basic things. Yeah, it's better than nothing. This is a good starting point. You have a template for the West manifest, but it would be nice to have like an editor here. You can also specify a repository. So if you have hosted your West project on your own Git, you can just put repository and give the link and you can get it, or even local one and so on. Yeah, repository here, you can either get the official one and it will fetch the different tags, or you can directly write the value that you want. Regarding the application, so in Zephyr, in this split, we have West Workspace apart and the different apps apart. So each time we want to build, we just need to import or create a different application. So creating the application, either we do create a new app, which is basically providing the SDK, the board, and we specify which sample. So we just need to get started from a sample. Here it will, you can search for, among the samples for the one that you'd like. And you do create, it will just copy the project and whatever you want. And there you go, you have your app. I'd like also to highlight that most of the time we're probably going to do import, because if you already have your app, you're just going to import it from whatever it is. So how to build the application? Well, we have many places actually. We have a button here in the list of apps. You can click build, or build here, or build, right-click, or on the project, just right-click build. Let me show you how it looks like. So this is VSCode, of course, and this is the extension, Zephyr Workbench, and this is the app. This is my workspace, and just one button, one click, and it is building. Live demo is working. So we can build the application as you expect. You can also have different ways for building the application. You can say it is pristine, not pristine, changing the options. And what is really nice here is you can do right click and also build or rebuild and so on. Yeah, for now, like basic features, but it's hard to make it have this on Windows. So the next step is going to be like runners, which basically I need to install the different debuggers or the Flash tools. We created a page called install debug tools. Basically, well, the concept is to create packs. So for the STM32, just one click, it's just going to download a bunch of tools for us. But it's a blocking steps because we might have some licenses problem, and for some vendors, you need to log in to download the software. So this is why when it's possible, we just directly download it. When it's not possible, we give you the link, and you can just go and directly download whatever you want. So at least you have a reference for where to go and to find the different tools. And for some tools, for now, it will automatically detect them in the path. If not, we sometimes need to manually put them in the path, but we're working on like having it automatically detecting all the tools. And then we have the debug manager. So debug manager is a view. We select which app we want to build. So we have something called multi-build. We select which one of the multi-build. It will automatically parse the project, detect where is the ELF project, what are the different options we have, and the runners. What is really nice in the runners, it will tell you that this one is compatible, the other one's not compatible, and if it's what's found by the path, and if it's not found, you might need to give the path, because sometimes we don't know where is the runner, where is OpenOCD. We might have different OpenOCD, just give it the right path here, and debug. So we call it one-click build debug, but it is like 2 clicks here or 3 clicks. Yeah, sorry for that. But it's still like, I think one of the simplest way for debugging in Zephyr. And PyOCD, I really like PyOCD, by the way. This is a very nice project. So if you're not aware of PyOCD, it's just a Python-based tool, so we can flash and debug Zephyr projects. It is supported by many Zephyr boards. So what Zephyr Workbench is doing here, actually with PyOCD, for each board you need to install a specific pack, and to do it manually you need to search for this pack, find the correct name, the correct version, install it, and then you run it, and so on. So what Zephyr Workbench is doing here, that we have this information inside the Zephyr code, so we can go and retrieve the pack automatically. When I click debug, if it's not installed, it's firstly going to download it, install it, and flash it, or use it. And just PyOCD, this is Zephyr. So Zephyr might not support all MCUs by default, and it will just here install everything on demand. So the launch.json, so each runner might have a slightly different template, just to make it work. So for now we use CPP debug. We do not use Cortex debug, because why do we need Cortex debug if CPP debug is working, just doing everything we needed? So Cortex debug is really good if you have like STM32 board, you use STLink directly. But here we're just we're trying to be like vendor independent, and it works this Zephyr way. So CPP debug is good enough. It is very good actually for everything we needed, and they support SVD. So if you give the SVD, you can see also all the peripherals. So you have all the features of Cortex debug using this one, and we have noticed that this one's slightly faster. Okay, so it is also common that we can open the terminal, because we really like to do the open terminal, right-click, open terminal, we run the different command, West and Zephyr way. So basically, we go here. So this is my application, right-click, open terminal. So here, it will automatically add some environment variables so we can get correctly, and it will open it also on the right folder. You can do West, and here you have the different commands to build and do whatever you want. Okay. So multi-build, yeah, multi-build is a pretty nice feature. Basically, for the same application, you can have different setups or build setups, because it is common like to have for the same application to build it on different boards. So here, the Hello World, I want to build it for the IMX RT. I want to build it for the STM32F7 and for the SP32. And just simply here, we can just, each build is going to have a different board, different config options, different overlays, different whatever the options that we want. And we also set an active project. So right-click, set active. You see this tick here. It means that this is the active project. So when you do build, by default, it's going to build it for this target. But you can still right-click and build whatever the setup you want manually. So this is a pretty nice feature. And what you expect for each application, you can have here like a specific conf files, extra conf file, extra DTC overlays, extra Zephyr module if needed, shields. So shield is pretty useful, and so on. And they will be added automatically to the build. It is also common to have your custom board. So we can also custom device tree and SOC for the device tree and the like SOC definition. This is like managed by Zephyr, but what is really might be needed was custom board. So when you create a custom board, you need to tell Zephyr Workbench to which board you'd like to build, and to detect this board, because Zephyr Workbench is going to try to suggest the board that you want to build for. So here so the custom board, it will parse. So firstly, it is auto-generated by West. So we must run West build or West, I don't know the options. It will just detect the board that might be listed inside the board root, or it might be inside a module. You know, in module you can have module root, board root inside a module, or you might add them with extra Zephyr module. So we have many options. So we just need to parse all of these options and suggest the different possibilities. Well, in theory, well, we had some issues with this one, but latest version, it's just detecting everything, and well, for now it's working very well. Yeah, SPDX. So this is becoming a thing, very important thing in Zephyr, well, with CRA. And so we can just do right-click on the application, SPDX. You can build the SPDX. You can analyze it. So for now, we have those tools suggested by the Zephyr documentation. But if you have other options, other tools, we are open to recommendation, and we can just add the different tools here. And it will just easily do the analysis and open everything for us. Yeah, we have a beta feature now, because we have noticed that a lot of developers really prefer Bash on Windows. Well, and they really prefer PowerShell. So we cannot find the right solution. It is much easier to do PowerShell on Windows, but we have a version. So the current version, actually, it supports Bash on Windows. It basically, if you have if you change the default terminal, you know, go terminal, integrated default profile Windows, you put whatever you want here. So we recommend Git Bash because it is easy to install and it works just fine. Yeah, so it will just use Git Bash instead. The only issue for now is debugging, because it is pretty complicated to have debugging working with Git Bash and all the links with Windows links, Windows paths, and Git Bash paths. Do the conversion, it's a nightmare. So we're just working on that. And we have tested this on MySys2, Cygwin, and the Git Bash. I don't know if there are other options, but these are the most popular bashes on Windows. And in this case, you don't need WSL, which is also, if you don't need it, it would be better not to install it. Other features, yeah, let's just do a quick here. So other features, you can just do right-click, configure, let's say menu config. There you go. You have the menu config here. You can just do whatever you want, the options. And so this stays because we have done that. Yeah, this is VSCode. And right-click, configure. Let's go GUI config. Yeah, it's on the other window. There you go. You have the GUI config. You can select your options and use it. What else? Yeah, the memory analysis, you can do the RAM report, ROM report. Let's go pun cover because I really like pun cover. This is for stack analysis to give you the stack, worst case stack usage. And actually in the pun cover, it will open a web page for you. And you can just go here and go to different projects and see the different files and see the different usage for the different. So here for the different files they use for the code and other things. So to have this stack analysis, you also need to add the config options. But anyways, it will just automatically run the whole thing for you. Okay. Yeah, you know, the analysis for RAM, let's say it will just do a RAM report, give you the different values. So how many bytes were used per each variable and so on. So these are just like a bunch of WES commands being run in the background. And we also support sysbuild. So there's option, right-click, sysbuild, activate or deactivate, and so on. So how the community can help? SOS. So try to find out, just try the tool, because with extensions, there are always a lot of problems. So we always need some help. We always need to add some features. It's never ending. So we always need some feedback and reporting issues. All the issues are, you can open it on GitHub. It is open source, so you just do an issue and yeah. And to contribute, we have a team that is working on this, but we have done the tool because we use it in our training. This is the main reason, because we don't want to lose our time on setup and other things. We just want to focus on Zephyr training itself. But we would like also the help from the community. And vendors, so vendors you can help. So you can add support for new runners and debuggers to simplify the debugger installation and integration, and providing the SVD files and how we can auto-detect them. So, and then, yeah, so why not suggesting and developing new features and spreading the word. Yeah, thank you. Just one final thing. So we have, so GitHub, this is the link, the documentation. Oh yeah, I did not mention documentation. This is a very important thing. Everything is well documented. Either on the website, well documentation, we have everything on the documentation on the website. We don't have yet a YouTube video, because each time we say that we have a new feature, it would be nice to add it to the video, and we remove whatever we prepared and so on. It is never ending. So, but the documentation is up to date. And we have also another thing. So let's say I will do new toolchain here. So you see always there's read docs. So it will just redirect directly to the documentation. So whatever the option you want, it will. We try to simplify it, but we can always improve the documentation. Okay, cherry on the top. So embedded team, I'm not sure if you have met them, they are here. So they have made a very nice tool for device trees. So we can configure the different pins. So it is based on using AI, which is cool. In my opinion, embedded is the only, I'm not sure if we can say the only, but the main tool that really makes sense in embedded systems. Well, there's also ChatGPT, but this one is pretty good. So the idea, they have a way to detect the different configuration and setup, so you can configure the pins, and this is can be installed as a VSCode extension, and they have promised us they will integrate it with Zephyr Workbench as well. So this is a promise. So embedded, if you're listening, yeah. Yeah, one more thing, Zazu. So Zazu is a simulator that we use in our training. This is it is on the marketplace, by the way, because in our training we have noticed that we don't need a physical board all the time. We can just directly use a simulated board, especially if you're doing a remote training. You can go and open this website to get started. And what is Zazu? So Zazu basically is this thing. So when you run the debug, or when you run the session, so you're going to have a simulated board on the other side. You can interact with it. You have buttons, LEDs, shell, I2C, sensors, temperature sensors, ADC, DMA, yeah, many other peripherals. And you can just interact with it. It really makes sense for training and learning. It might be used for testing, but the main purpose, at least from our side, is just mainly training. But you can also share it with your colleague if they want to use something, or teach them anything about that. Also, it works. It is based on Renode, so we did not recreate the simulator. The backend is Renode. The front end is just an extension, and you just select the project, click on debug. It will automatically generate the setup for Renode and the template and so on. We have a bunch of templates. You select one of them, and it will open the board. You can also tweak it, create your custom board. This is like this all in the documentation if you want to do advanced boards or beyond the template. Voilà, merci, and thank you very much. So, yes?
Yes, one standard use case we are having is basically, checking out a project which is already existing. Let's take the example of dev container. It's actually quite easy. You just say, here it is, and when you click, and what is done. How is it with your tool? Is it like basically if I say, hey, here, this is kind of my Git repository with all the setup, then does it do automatically checking out the correct SDK versions and all dependency, or do we have to do it before?
There's no way to automatically detect the correct SDK version. You still need to manually say this SDK should be with this application. And here, even in this app and this extension, you can just right-click, change the SDK. It makes sense in your setup because it is scripted and you have a way for doing it. But I'm not sure if there's an automated way to detect that. And if it's possible, we would like to integrate this.
Yeah, probably need a config where you kind of save it and then commit it with it.
Yeah, it would be a solution. Yes. Sorry. Yes.
A comment on that first. It is common to have a Zephyr SDK version file in the root of the folder, which specifies the version. You could pull that from there. That's in the Zephyr repo plus some downstream.
But the problem is not only the version, it's also the which architecture.
So my question, the application configs, are they stored locally so that other team members get the same config, or do they have to manually set them up?
So the application config, you mean the settings of the VSCode settings?
Port A, port B, port C,
Oh.
is that local or is that?
Good point. When you import a project, it will detect if it's a Zephyr Workbench project or config. It will tell you would you like to use the same config. Well, here I'm not sure if it's going to work because you might have conflicts, but in some cases it will work. If not, it will ask you the questions and to fill it up with the right, so like the different values. Yes.
Follow-up question for you. Would you recommend to add it to the Git, your configuration for the workbench, like what you just mentioned?
About what the
About the configuration of the
VSCode?
Yes.
No, it is more like local for each setup. Because more the things are just the path for the SDK, the path of the whatever, but just the board, and the board is easy to set up. Sorry, yes.
I think Andreas was first.
Yes, Andreas.
Speaking of automation, have you thought about sharing this configuration with some CI tooling? Because it's great to have it like a QID experience on your local desktop machine, but it also has the same problem of integrating this experience in the CI and a continuous integration, and that's where I think the real pain comes in, because it's not really reproducible as I get from this discussion.
So it is now reproducible. Well, what we have the solution is I'm not sure if it's we had the discussion. I think it is already developed, but when you do you give your config, the .conf, you can put a variable. I forgot what is it, but you can put a variable slash the path relative to your application. So in this case, it will become reproducible. So all the path will be relative to this folder.
Okay, but still in my CI setup, I have to set up every two chains I want to use for every container, so it's not
Yeah. By the way, regarding CI, we have in the roadmap like a panel for the CI to have all the setup. So here we are really open for like having the best CI we can, but we don't have the capacity yet, and it is not something that is important for our training at the current time. So this is why we do not focus on that. And this is where really the community, this is what we're asking for, like the contribution of the community for this part. Sorry.
So maybe I can.
Sorry?
So I have a linked question/remark.
Sure.
So for the CI thing, what we do is we do everything in a container. The container is actually built by CI, and we pull it, and then in the container contains the SDK and with itself and all the dependencies. I guess it's not possible to use that container from the workbench.
I'm not sure how you're using your dev container, but you can put Zephyr Workbench in a container and use it from inside the container. There's no problem here. You can, all the standard way for using the container, it works. Yes, Tobias.
I'll follow up with you later.
Okay, sure. Thank you. Yes?
Yeah, I'm wondering about like compilation flags in Zephyr to West. You can add like deconfig optimizations, and how configurable are the build commands in this?
Well,
So
you have.
let's say for one build, I would want to know optimizations.
So these are just config options. Like you can just on the project.conf and put whatever you want. This is like specific to every application.
Yeah, but let's say for one build in West, you can just type them, right? Compiler options can be added to the end of the West commands.
How do you add like -d something?
Yeah.
You can still do the -d your options. I just opened the menu. I showed like a couple of them. One of them is just extra argument.
Okay.
You can put whatever the extra argument. But most of the time you don't need those extra argument because most of the time you -d and the config. And the good practice just put it in a fragment or a project.conf. Yes. Yes.
Is it extensible? For example, let's say I want to not just build, but maybe I want to run the unit tests, or I want to do MISRA checking. So are the menus configurable in a way that I can add the different activities besides the ones that support the build, debug, run, flash?
So for now we need to do it manually, but we are thinking about creating templates, like fragment templates. One of them is, let's say for Tracealyzer, like for Percepio, because so Tracealyzer, they have like now a free version, so it would be nice to have it automatically supported. So it will just add extending the project.conf with some fragments. So I think we can do the same thing for MISRA checking and automatically like expand, because there are many good ideas, but we need help. We cannot like a single company do all of this. Yes.
I heard you say you're not convinced about WSL, but it's supported.
So I am convinced with WSL, but most companies, they avoid it, or they have restrictions, or they don't want to install it, or many things.
Do we have a quick vote who's using WSL for Zephyr?
Yeah. Yeah. I use it also because it's faster.
Maybe who is using Windows? Because
I think no one here is using Windows. I use Windows actually. Yeah. Yeah, but WSL, it's also faster because the file system is a bit faster for the. And on Zephyr Workbench, we recommend when you work on a folder to do, if it's possible, to do an exclusion and the antivirus, because the Windows Defender makes it very, very, very slow, but still usable. And it's better than nothing, because this is the only run that's going to be slow. The other runs will be pretty fast. It is slightly faster with Git Bash, by the way. Yes, other questions? Yes?
I noticed in the beginning of your workflow, you were selecting a project and you said you copied the project, but I don't know how people normally do things, but I never copy the samples. I just do a build command within Zephyr and have it go to a build directory. Is there an option to not do the copying of the files and stuff?
You mean the sample?
Yeah, all the samples and test cases. I've seen that mode of using Visual Studio to say, do a project, and copy the files. And I'm just like, but why do I have to copy them? Why can't I just leave them there and have the build directory expand out in a different location?
So I will answer about two things. The first thing, is it possible? Yes. Instead of create, you use import. So import is just an existing project. It's an import existing project and you can just use it. And the other thing, yes, we might need to copy it because I'm not going to use a sample. I'm going to, after all, do my application based on a sample.
No, I get that. I had the same conversation before with my copy.
Yeah, and it is also nice like to have a way to get started easily. Yeah, thank you very much.
Thank you.
Thanks.